This video, I'll demonstrate how exponential and logarithmic function works. So the first thing that you need to understand is that you have a to the power of n, right? What is a? A represent the base, right? A represent the base, and then n represent the power or the exponent, right? Or the power or the exponent. So that's the first very important thing. So in this video, we want to focus on how do you now then convert from an exponential function to a logarithmic function, right? So this can also be rewritten by in a wasn't a good example of an exponential function would be y equals to b of x. So this is an exponential function, right? But then there's something we call the inverse, right? The inverse function of an exponential function is a logarithmic function. What do I mean about the inverse? Maybe let's start there. So the inverse is something we obtain. So the inverse is something we obtain. Um, it's something we obtain when we interchange x and y. So the inverse function is something we obtain when we interchange x and y. So inverse, we interchange x and y. So don't worry, this will make sense in a minute. Right. So the inverse, we interchange x and y. What do I mean? And then in this case, I was saying that we have x here, and then we have b to the x, b to the y, sorry, b to the y. How do we then from here try to solve for y? That's when we introduce what we call the log function. You understand? So how does this work? If you want to solve for y in this case, you need to now and then say y is equals to log base of b times x. Right. So this is moving from an exponential to a logarithmic function. Okay, let's unpack some rules on this, and then it will make sense as we go. So now let's say um, if you are given if you are given x equals to b to the power of y, right? Then y is equals to log base of b times x, right? If you're given x, so if you're given something in exponential form and then you have to convert it, or you have to solve for y, you convert it into logs. That's what this law is saying, right? So let's put a note down on this. Let's put a note down. Bear with me. So we're gonna put a note. So if if you are given something in exponential form, in order to solve it, you need to change it to logs, right? So this is simple, guys. So let me just also give you another form of how you could change this, because it's very important to understand, right? So um you have a number. Let's just call a number. We have a number equals to a base, right? And then an exponent here. And then to convert this into log form, you're going to have exponent. So this becomes exponent equals to log, right? And then you have the base here, and then you have the number here, right? It will make sense. To make sense. So you have a number. A number is represented by x, and then a base is represented by b, and then an exponent is represented by y. Hence, we had x equals to base b to the power of y, and then this in exponential form, let's put it in red, in exponential or in logarithmic form is equals to y equals to log base of b times x. So this is what? So this is exponential xp, and then this is logarithmic. So this is something that you need to understand, and then you need to grasp as you move. The first very important thing when you're dealing with exponential and logarithmic functions is to understand how do you convert from exponential function to logarithmic function, right? So let's move on. There's something very important that you will encounter in this section that you will need to understand quite clearly. So let's unpack this. Let's look for a nice color. Okay, this looks nice. So number 2, okay, that was number 1, converting from exponential to logs. So if you are given, a to the power of x equals to a to the power of y. In this case, you are saying that the two bases are the same, but the exponents are different. So in this case, if the bases are the same or between the equal sign, that means that your therefore, if the bases are the same in this case, you will therefore have your exponents to be equal. So bases are the same. A to the power x is equals to a to the power of y. Then what happens to your exponent? The exponents are equal. Right, let's put a note. So when you have the same basis, then the exponents are equal. So the bases are the same, right? For quick, maybe let's do a quick example on these to make it more make sense. So let's say you have 4, 4 to the power of 2, and then you have 4 to the power of x, right? So the bases are the same. That means 2 is equals to x. You understand? So bases are the same, then the exponents are equal. So this is something that you need to take note of. This is how it works. You could interchange this one way or another, but this is how it works. So you need to know that if the bases are the same and then you have an equal sign in between, then the exponents are equal. But do not assume that if you have 4 and then to the power of x and then 2 to the power of x, then this doesn't mean that 4 is equals to 2. Doesn't mean that. So you must not confuse this part. Understand how the law works. The law says that a to the power of x is equals to a to the power of y, then 4, or then x is equals to y. So this x and y could represent anything, but that you need to understand the bases are the ones that can be the same, but not the exponent being the same. Then you assume that it's the other way around. I hope that makes sense. So let's move on to the next law, and then we'll unpack this further. So right, so these are some important laws of logarithm that you need to understand. So okay, what happens now if you are given if you're given y is equals to log base of b, and then in the inside you have the x, right? So this is the brackets do not mean anything. This is the same as y equals to log base of b x, right? This is the same thing. Nothing has changed. Then if you have something like this, so if you're given a logarithmic function, you need to convert it into exponential in order for you to be able to solve, right? So in this case, what happens? Now this will change to z, to what? To become, we'll say then, if you want to convert this into exponential, what do? You just simply take this b and make it the base here. You understand? It's a base here, just make it the base on the other side and then remove the log. So this becomes b to the power of y equals to x. Right. That's what it becomes. That's what it becomes. That's what it becomes. So that's how you simply do it. So maybe let's take an example. An example. So you have, let's assume that you have log base of 3 x is equals to y, right? So, and then I say convert into exponential. So we say convert into exponential, and then this just goes there. You have x equals to 3 to the power of y. So you just move the base here and make it the base on the other side, right? Maybe another example. Maybe another example. Let's just say you have log base of 4, and then you have maybe x is equals to maybe z, right? Doesn't matter what it is. So convert into logarithm, and then you just take this 4 and make it the base on this side. You have x is equals to 4 to the power of z. That's what it is. That's what it is. So you just take the base, move it, and make it the base on the other side. So that's how you convert from log into exponential. And when do you do this? When do you do this? That's the important question. That's the important question. So let's put a note down and then understand when do we do this, right? So when you are given a log, was it log function? And when given a log function or a log problem, and then you need to solve it, what do you do? So in order to solve, you need to convert into exponential. So if they say solve for x and then they give you a log equation, what you need to do in order to solve that problem, you need to convert it into exponential. So if you are given maybe an exponential equation and then you're required to solve for x or y or whatsoever, and then in order for you to solve that exponential equation to find the answer, you need to convert it into logs. Yeah. So in the next video I'll do examples on this, but the first thing that I need you to understand what's going on, and so this is a build up to the problems that we're gonna sort of like solve in the next couple of videos. So now let's unpack another law, right? Another important law of logs that you need to understand for how to convert between exponential and logarithmic, and also how to solve the problems in logs. So yeah, so let's say if you are given if you're given log base of b, and then maybe x is equals to log base of b, and then in the brackets you have y. So in this case, what is happening? We have the same bases. The bases are the same. In this case, the bases are the same, right? The bases are the same. What happens? The inside, that means x is equals to y. So because the bases are the same, then x is equals to y. That's what this law says. So the bases have to be the same, and there's nothing plus here, there's nothing plus here. So if this wouldn't apply if there was a plus 4 here, this wouldn't apply. But because there's nothing here, then the base here, the base here and the base here is the same, and then x is equals to y. The insides are equal. So maybe let's put a note. So I refer to my insides. When I say insides, I'm referring to this part. These are my insides, right? Let me just also put a note. I call this inside, right? So when I say insides, I mean the whatever's inside the brackets of this problem. So let's make a note. If the basis of the function log function fn for function are the same then their insides are equal. So the insides are equal. So for example, let's maybe make an example, just a random example. So let's say you have your log base of 7 and then you have x plus 2, it's equals to log base of 7 of 6, right? And then I say solve for x, right? Solve for x. I say solve for x. How do you solve for this? Then you come and say, okay, in this problem, my insides are different, right? But what is important? The important thing is that my bases are the same, right? So my bases are the same, and then what's going to happen to my problem? How am I going to solve this? Since my bases are the same, I can now then say x plus 2 is equals to 6, right? And then how do I solve for x? I say x is equals to 6 minus 2. You transpose. So to transpose is to take the 2 to the other side, and then it's going to change sign. Now it's going to become minus 2. And then what is x? It's equals to 6 minus 2 is what? It's 4. So that's how you solve for x in something like this. Yes, in a test or exam, it will come a bit more complicated, but this is the start. You understand? Understanding the basics. So you wouldn't do this if you had something like a plus something here. You wouldn't be allowed to do this, but we'll unpack that later. But the main thing is that the fact that the bases are the same, and then we equate their insides, right? When the bases are the same, we equate the insides. Let's make that note so that you remember. When the bases are the same, we equate the insides. Right. So when the bases are the same, we equate their insides. So that's one most important thing that you need to note. And then from there, you'll be able to get to grasp this and be a master in this, so that you understand what's going on, like quite clearly. So okay, I want to do a couple of examples, and then so that you can be able to understand, right? So okay, let's say these are a few more examples, but this is examples time, so we'll just pretend that we haven't done any examples. So let's say, for example, let's just call it example 1. Let's say I say solve for x, and then what are you given? You're given 2x equals to 16. Okay, solve for x, you're given that. So this, how do we then solve for x here in this case? So this is what? This is 2 to the power of x, and then this is 16, right? I just learned a new skill on my calculator that it could help us change the 16 to be something to the power of 2, right? So we want the 16 to be something to the power of 2 because we know the law that says a to the x is equals to a to the y, and then if it's like this, then we can say x is equals to y. So this is what we desire to do, or this is how we desire to solve this. So now go on your calculator, punch 16, press equal sign, press shift, press fact. So it will tell you that 2 to the power of 4. So you know that then you get 2 to the power of 4. Right. Okay, let me repeat those steps. Punch 16 on your calculator, press equal sign, and then press shift, and then press fact. And then it will tell you it's 2 to the power of 4. So what happens now in this case? What happened? Now the bases are the same. The bases are the same. That what do we do with the exponent? We equate the exponent. So this is therefore x is equals to 4 in this problem. X is equals to 4. Right. So this is how you get to solve this problem. So let's maybe do another problem and see. Right. So another problem. So this is our problem example number 2. But now we have 2 to the power of x equals to maybe, let's say, 17. Right. How do we then solve for x here? Because there's no way we can change 17 to the power of, we can make the base of 17 to be 2 and we have a certain power. Even if you say 17 on your calculator, 17 equals sign, shift, and fact, you don't get anything, right? So what do we do then? If it's something like this and then you can't change and we need to solve for x, we need to now then convert into logs. Understand? To solve something like this, we need to convert into logs. So how do we do it? How do we do it? So we have the exponent, right? So we're gonna say, to convert into logs, we're gonna say x is equals to log, what is our base? It's 2, and then 17. You understand? 17. So now we can punch this in our calculator, and then what do we have? Okay. So log base of 2 and then 17. This is equals to 4.09. So that's the value of x in this case. But how did I convert here? Let me just remind you how we did that. Let me get the green pen. So we had a what? We had a base, and then we had a exponent, right? We had a base which was 2, we had an exponent which was x, and then we had a number. We had a number which was 17, right? Maybe let me just write down in brackets, and then we had a number 17, and then we had the base which was 2, right? So that you can follow with me, right? In order to convert to log, so this is in exponential. Don't forget that this is in exponential form. So after we had this, what did we do to convert into logs? So in order to convert into logs, we said what? Exponent it's equals to log, and then we had base, and then we had a number here, right? That's how we converted. So yeah, it might seem unclear now, but the more you do it, the better you understand, right? The better you understand. So this is in log form. So understanding this forms a foundation of understanding or being able to solve problems in logarithmic functions. You understand? This helps you to solve problems in logarithmic functions. So if you can understand this, you will be able to solve any problem in logarithmic functions. So let's go on and do another example on this. Right. Another example on this, and then we'll see how best we can be able to solve this, right? So let's say number 3, right? You're solving for x. Solve for x, right? Solve for x, and then you have log base of x, and then you have 4 is equals to 2. And then I say solve for x for me. How do you then solve for x? If you're given a function in logarithmic form, in order to solve for x, you convert it into exponential. How do we convert this into exponential? We simply take the x and make it the base on this side, because it's a base on this side. That means this is 4 equals to x squared. We've converted. That's it. There's nothing. It's not complex. It's not complex. It's very, very easy. Then how do we then now solve for x in this case, right? How do we then solve for x in this case? And then this could be 0 equals to x squared minus 4, and then 0 is equals to difference of two squares, I think. I don't know what they call that, but I've claimed it to be this. You understand? This is how you could solve for x, and then your x is equals to 2, or x is equals to minus 2. You understand? So there's so many ways to do this. So one other way, if you have 4, okay, let's just say, okay, you have 4 equals to x squared. In order to solve for x here, you square root this side, and then you have a square plus or minus square root of 4. And then what is this? X is then this, you have plus or minus 2 is equals to x. So that's another way to solve this. So in this case, right, in this case, so let's make a note, a quick note. We need to make an important note here. So in so let's remind ourselves, in order to solve for x, we need to change into exponential. Why do we need to change it to exponential? Because we're given the function in log form. Because we are given the function in log form. Right. So that's what we need to do. That's what we needed to do. So this is how you get to convert from exponential to logs, and from logs to exponential. I hope I've demonstrated everything that you need to know on this chapter, or the basic foundation. In the next video, I'll demonstrate the logarithmic rules so that you understand the log rules that you need to learn and apply in this chapter of exponential and logarithmic functions. So thank you. Keep learning, keep progressing, and all the best.